So how can we get labeled image data to train on? Even if we took all these pictures, we would have to go outline the deer on each one, or at least say whether there's a deer or not. Um, well, we could label it ourselves, like you in taking the class, you as a person could go label it yourself, or I as the professor could label it ourselves. If we worked at a company, we could get interns to do it. Or as a professor, I could ask undergraduates or graduate students to do it. Um, we could hire people to do it on a large scale piece working outsourcing platform like Amazon Mechanical Turk, which is a name I would not have chosen. You could look it up and figure out why they called it that and maybe what they should have called it instead. There are various algorithms that will try to label things for you, which is their own complicated thing we're not going to get into. There is a famous AI researcher. I don't exactly know how to pronounce her name, but Faith A. Lee, perhaps. And her Wikipedia page points out that she led the development of a massive database designed to advance object recognition in AI. So 14 million images. And I think she had some grad students working on it and some Mechanical Turk workers. Um, and then that database became the foundation for a contest of like who can write the best AI to detect to label images in that. So it's a cornerstone of that advanced innovation. People have pointed out that there are mistakes in some of those labels, so you could read about it in these papers. Um, Also thinking about uh, data set variety and such, there's an organization called the Algorithmic Justice League, and they have a documentary um, that I recommend you watch. And the founder showed 1,000 faces to facial recognition systems and asked the systems to say whether the face was female or male. And the software found it hard to identify dark-skinned women, probably because they didn't have as many dark-skinned people in their data set as they had light-skinned people. And so that's important, especially if it's going to be like uh, gives you access to your apartment building or something, right? But there's also the dilemma of do you really want AI to be more able to exactly identify you? So that's a big thing that needs discussion. Here's one way to think about the variety of data that we probably need. This could be the starting point of a checklist if you want. We should think about subject variety. Do we have a wide array of people who look different from each other? Are they in various poses, for example? We could look at environmental variety. What's the weather? What's the background scene? What's the lighting? We could look at sensor variety, like we talked about, try different cameras, different resolutions. So where would you put like the zoom level on that list? Think about it for a sec. Well, I'm okay with thinking of it as environmental variety since zooming in kind of changes how much background there is, so it kind of changes the background scene. Or you could talk about it as sensor variety since it kind of changes the image resolution of a subject. If you're zoomed out, but then you just crop in that one subject, then you've kind of got a lower resolution version of it. So there doesn't have to be a single right answer, but you should be thinking about all these things as you are collecting data or planning your data collection. Um, we've said getting all this data and labeling it is a lot of work. There's methods for saving some work that are called data augmentation. Let's say you have a microscope kind of image and a by-hand segmentation for it like this. So this is a yeast cell in a transmission electron microscope. And we're interested in these little things inside the yeast cell called autophagic bodies. And someone sat down and outlined each of them that they saw. So here's our mask for it. Um, you might figure, well, the orientation of this yeast cell under the microscope is pretty much arbitrary, right? Like it's in a fluid initially, and then you kind of freeze it. Yeast cell could be facing this way or that way. It doesn't really matter. We could take this image and flip it around. Like here we've flipped it up, down. Here we've taken this image and flipped it left to right. Here we've flipped it left, right, and up, down. And we could take the segmentation and flip it to match. And that would give us almost like four separate yeast cells for the price of one. And we don't have to relabel it because we can just reuse this labeling flipped. There's other data augmentation methods too, slight rotation, slight zooming, changing the contrast, etc. So that is such a good idea that it's a built-in feature for some neural net software. It's called data augmentation, I said. This has way more details than you probably want right now. In some cases, it's even automatically applied, and it might be important for you to go turn it off. Uh, while data augmentation is often a good idea because it's in some sense free data, here's an analogy to consider. Suppose we want to know how well a new blood pressure medicine works for people. Which of these two study ideas is better? Study A, get 100 volunteers, give them the blood pressure medicine, and then measure their blood pressure after 60 minutes. Or study B, get 25 volunteers, give them blood pressure medicine, measure their blood pressure after 60 minutes, have them come in the next week and do it again, then again the next week, and then again the next week. So we get 4 data points per person for a total of 100 data points. That reduces your costs to recruit people and do paperwork and all kinds of stuff, right? So that would be an easier study to run. Which of them is better? Well, we should say that from a science perspective, study B isn't as good as study A because you aren't learning all that much new information about how people in general respond to this from the 3 extra measurements on the people that you already have. Idea B doesn't give you 100 separate data, independent data points like A does. If there's some medical condition that produces strange results about this medicine, you're a lot less likely to see it if you do study B than if you see study A. That's why above I said that flipping the image all around is almost like 4 labeled images for the price of 1, but it's not really as good as 4 completely independent, separate labeled images. From a cost perspective, study B is a lot cheaper than study A. Even cheaper would be a new option. Option C, just get 1 volunteer and measure them 100 times. You'd learn a lot about that one person. You'd have a lot more precision about them, but you would entirely lose the ability to generalize to people. So we got to think about these things as we are setting up studies. Let's take a few moments to think about what are some image processing contexts where you would not want to do this kind of flip the image data augmentation. So think about it for a minute, then unpause the video. Well, some ideas that I had would be street scenes, like flipping a stop sign left-right is probably not a great idea because the letters would be backwards, right? Flipping a street scene upside down is definitely not a good idea unless you expect your self-driving car to be upside down sometimes. Turning images of plain text into images of text into plain text, which is called optical character recognition or OCR, flipping it back left and right or up down, probably not a great idea. I would say a key word to think about for these things is symmetry. Is it, in nature, is this thing left-right symmetric? Or a fancier term could be rotational invariance. What about taking images from a trail camera or that picture of 2 eagles? Would you be okay flipping that left-right to do data augmentation? What about flipping images of a deer in the road left-right? Do you think that would be okay? Um, so in an earlier video, I mentioned all the ways we'd want to pose a fake deer to take pictures, and it sounded exhausting. Some people have talked about making photorealistic simulated data using kind of the same stuff they use for movies, CGI software, or even things like Grand Theft Auto. Some current buzzwords are synthetic data and digital twins. The nice thing about that is then it's easy to uh, say to the computer program, well, you know that there was a deer here because you rendered that photorealistic image. So it's easy to generate a label or a mask saying what's in the scene or where the stop sign is or something. So no human labeling of images is needed. I'm going to say if you do synthetic data, you should go test it on some real data later. Probably not too controversial there.